All right, thank you so much for joining us today. And in this video, we are going to learn integration by substitution, all the tips that you need, and then the tricks. Right, let's start. So we have this function here, or let me say this integration here that we want to do. But basically, we are going to use integration by substitution or U-substitution. Right. So what are we going to do? What is the first trick that I need to learn? Now, anytime you want to do integration by substitution, look at the degree. Like you want to do like horizontal asymptote, always we check the degree, right? So like this is like 1 and this is like 2. So always your U should be the one with the highest degree. So it means that here my U, I'll let my U to be equal to x squared plus 5. I'm not just choosing x squared, but I'm choosing everything that is going with the what? The highest degree. Good. I will show you what will happen. So now it means that this is what the integration is going to be. The integration is going to be 3x divided by, now we are saying that x squared plus 5 is equal to u. So the denominator is going to be u dx. But the idea with u substitution or integration by substitution is when we are changing everything from x to u, then everything should change to u. But we have x here, we have the x here. So we can make use of this to make sure that the x is out and then the x is also out. So since we need to change the x, then we need to differentiate this function with respect to what? X. Good. So this is going to be dx. Oops. This is going to be du divided by dx, and this should give us 2x, right? So this is what you are going to get. Now we have the x here that we want to change. So what can we do? I will multiply this function by this. So I'm going to have something like du is equal to 2x dx. But look at something here. I can see even x here and the x here. So I can basically even write this one as 3 divided by u x dx. Do you agree? Yes, you agree with me. So this here is kind of this here. So all I need to do is like divide this one by 2, divide this one by 2. So I'm going to have du divided by 2 is equal to x dx. So now I can see that the x, which is the same as this, is the same as du over 2. So now my integration is going to be integrate 3 divided by u times du over 2. So what do you see? You can see that I have moved from all x to what? All u. So that's why we call it u substitution, right? So now what can I do? Now I can factor 3 over 2 out, and it is going to be left with 1 over u du, right? So we learned that anytime we see like something like 1 divided by something and then the degree is 1, then we need to think about the natural log, right? So this is going to give us 3 over 2 natural log of u plus, this is indefinite, so I need to add c to it. But you see something here that my integration here is like in terms of x. So my final results too should be in terms of x, not u. So it means that since I have u here, I need to change it. But what is u? U is equal to x squared plus 5. So finally, our results is going to be 3 over 2 natural log of x squared plus 5 plus c. This is integration by substitution. And one thing about integration by substitution is anytime you can use integration by substitution, when you do the substitution, you can change everything from x to everything to what? U. So if the question given to you, you cannot use integration by substitution, then when you do the u substitution, you will see that your function is going to be in terms of x, right? It means that you cannot do that. Then you need to think about integration by parts, right? So this is the final result, final answer that we are going to get, right? Let's look at So you see the trick here, like the way we did for a rational function. Let's look at when we have like the root function, right? A radical function. What can I do? Of course, I see another one. This is having a degree of 2 and this is having a degree of x. So somebody will be like, now what is our u? Are we going to choose u to be equal to square root of 1 minus x squared? No, that's not what we are going to do. But rather, we are going to choose u to be equal to what is under the root. So my u should be equal to 1 minus x squared. Good. So that is how it is. Now remember, we can write this integration as, we can write this one as integration x 1 minus x squared to the power 1 over 2 dx. So anytime you have something inside a bracket to the power, you don't take u with everything. You just take the one in the parentheses, because this one is the one with the highest degree. This is just 1. So it means that when we differentiate this, we will be able to get this one out. Now I can simplify this, and I know that now the one here is the same as this and is equal to u. So this is going to give us x u to the power 1 over 2 dx. Can you see that? Because everything here is this, and we are saying that it's u. Now what can I do again? I can just write this one as u to the power 1 over 2 x dx. So now what I need to go and look for is, I need to go and look for x dx and come and do substitution so that I can do the integration. So now let's come here. I need to differentiate u with respect to x. So this is going to give us minus 2x. Let's do cross multiplication. This will multiply this. This is over 1. This will multiply this. So we are going to have du to be equal to minus 2x dx. So we can see that we have x dx here, x dx here, but the only thing left is minus 2. So we divide this one by minus 2, divide this one by minus 2, and we are going to have du divided by minus 2, which is the same as x dx. Nice. So what can we do here? We pick this one and then we do substitution here. So this is going to give us integration u1 over 2 times du over minus 2. So I'm replacing x dx by du over minus 2 because this is the same as this. Good. Now what can we do? We can do something small before we start the integration. I can factor minus 1 over 2 out, and it will be left with u1 over 2 du. So now we've done the hard work. This is now the beautiful thing, the joy. We just need to just do the integration and we are done. So this is 1 over 2 plus 1 divided by 1 over 2 plus 1. So everything on the top here is the same as down here. Then this one is indefinite, so I need to add plus c. This is going to be the same as minus 1 over 2 u to the power, so half plus 1 is 3 over 2 divided by 3 over 2. Now let's look at something here. I have negative half here, or let's say 1 over 2 here and this one here. So 1 over 2 is like, I have this 1 over 2 divided by this. So divided by 3 on 2, and this is 1 over 2 times 2 on 3. So 2 cancel the 2, so I'm going to have 1 over 3. So this is going to give us minus 1 over 3. Oops, I didn't bring my c. So plus c, and then I'm going to have negative 1 over 3 u to the power 3 over 2 plus c. And don't forget, now anytime you are doing u substitution, when you are done, you need to make sure that the u is taken care of. So now here our u is 1 minus x squared. So we need to make sure that we plug that in. So what I'm going to do is I'll put the final results on the top here. So I'm just writing this, but now doing substitution for u. So this is going to give us our final results, which is going to be minus 1 over 2. Then what do we have? U is 1 minus x squared to the power 3 on 2 plus c. So this is our final results here. So this is integration by substitution. Kind of very simple, but what you need to do is you need to practice, practice, practice before. When you become good, then now you know the vibe, right? You can, actually try to do the shortcut and stuff. Now let's look at this one too. So you saw that we did this one here, there was no squared. So we just pick everything at the denominator to be u. Now let's look at this one too. So you see that the one with the highest degree is basically x squared here. But this one is to the power 3, everything to the power 3. So what will be u? Guess what? If it was u, what will be u? What did you say? 1 minus x squared. Yes, 1 minus x squared, you are right. So 1 minus x squared will be our u because the degree here is more than this. So let's assume that the degree here is like 3. Then, anytime this one is greater than this, we need to pick the top, right? So this is what you are going to get at the end of the day. Good. So you see that we didn't include the 3, like we are choosing u to be this. No, we don't need to do that. So it means that if I choose u to be this, then now what will be my integration? My integration is going to be 3x divided by u to the power 3. Do you see that? Dx, right? And I can rewrite this one too as 3 out, right? Or even let me maintain the 3 on the top there, u to the power 3. Then I group the x. So when I do the u substitution here, then what I need to do is I need to group my x. So I have now x dx. The same thing again. We differentiate this function with respect to x, then we will look for x dx. Again, it's not always the case that we need to look for x dx. Sometimes we just need to look for the x. Sometimes we need to look for x squared dx. Sometimes we need to look for x cubed dx. So it's based on the question, right? So let's go. Du over dx is equal to negative 2x, right? So same assumption again. Du is equal to minus 2x dx. We have x dx, x dx. So we divide by minus 2, divide this one by minus 2, and we are going to have du over minus 2 is equal to x dx. So x dx, x dx, we can replace it by du over what? Negative 2. So 3 over u to the power 3 times du over minus 2. Nice. So I challenge you to pause the video on D and try before you continue to check, right? So I can factor 3 and minus 2 out. So minus 3 on 2, 1 over u to the power 3 du. And this is going to give us minus 3 on 2. So let's do the integration. Okay, let's simplify first. So we can simplify this one as u to the power minus 3 du. And this is going to give us minus 3 over 2. Then this is u minus 3 plus 1 divided by minus 3 plus 1 plus c. So this should give us minus 3 over 2 u to the power negative 2 divided by negative 2, right? So now the idea is that we have negative 3 on 2 divided by minus 2. So minus 3 on 2 times minus 1 on 2. So this is going to give us 3 on 4, right? So we are going to have 3 on 4. So this is going to give us minus, no, there will not be minus 3 on 4 u to the power minus 2 plus c. Don't forget, what was u? U is 1 minus x squared. So this is 3 divided by 4, 1 minus x squared plus c. Minus 2 should be here. So this will be the final results for the C. So I'm challenging you to do the D. I mean, this one is definitely is the D is definite. So maybe what you can do is like you can decide to what will be the U, right? Because since it's definite, now when we are doing the integration, remember we are not going to add plus C, but you are going to evaluate it at 1 and 0, right? So D is basically the same thing. So what will be U, right? So your u is the choice that you need to make. So what will be u? Okay, you are saying that u is x squared plus 5, and that's right, right? So if that's the case, then what will be the integration now? The integration now will be from 0 to 1, 2x. Now we are saying that x squared plus 5 is u, so we are going to have, let me put u dx. Then what can we do? We can say that this is the same as, I can write this one as group all the x, so I can have this one like 2u x dx. Do you get it? So basically now we need to go and make sure that we look for x dx. So du over dx is equal to 2x, and then what will be du 2x dx? So I have this one here, I have this one here, so I need to divide by 2, or you can add the 2 to this one, like 2 times x dx, and replace it by du. But if we cannot see that way, then x dx is here, so I need to divide by 2, divide by 2. So my du over 2 is equal to x dx. So this is here, then I replace by this. So this is going to give us integration from 0 to 1, and then I'm going to have 2u times du over 2. But happy, this cancel that, and we are going to have from 0 to 1 u du. Good. Now let's go through the integration. This is to the power 1, and remember this is not, you know, a fraction or a rational function. So don't think about the natural log. It is when you have 1 over, then you think about that. So since this one is 1 and it's not a fraction, we can write this one as u1 plus 1 divided by 1 plus 1. But here we are not adding plus c, but we are moving from 0 to 1, right? So this is the same as u squared divided by 2 from 0 to 1. Now don't be on hurry to plug in 1 here and 0 here, because this 1 and 0 is not for u, it's for x. So what we need to do is we need to go and look for u. What is u? What is u? U is x squared plus 5. So we are going to have x squared plus 5 all squared divided by 2 from 0 to 1. Now we can do the substitution, right? We can plug in 0 and we can plug in 1. So let's go. When I plug in 1, I'm going to have 1 squared plus 5 all squared divided by 2, then minus, then I plug in 0, 0 squared plus 5 all squared divided by 2. So what will be the final result? Here will be 6 squared divided by 2 minus 5 squared divided by 2. So this is 6 squared is like 36 divided by 2 minus 25 divided by 2. And we know that since the base are the same, we can just subtract the top. And I think we are going to get something like 9, right? Yes, I think so. No, 9. Here is like 36. I have 5, it's supposed to be 11 rather. Yeah, 11 divided by 2. So this is what you are going to get for integrating this function right here. So we are going to get 11 over 2. Now, are you challenging yourself to do question E? Okay, you are doing that. Okay, try. So try it, can pause the video, try it, and let's see what you are going to get. Then you just continue the video and then you watch. So I assume you have paused it, you have done. So I'm just going to continue from here. So this kind of the same idea, we have x, 2x of them. So what we just need to do is we need to pick the one with the highest degree. So now what will be my u? My u will be x squared. Yes. So it means that if that's the case, then I'm going to have integration 2x e to the power u dx. So I'm replacing the x squared by u here. When I finish, I group like terms. I make sure that u stands alone, x stands alone. So I'm going to have 2u x dx. Then I need to make sure that I use this function to look for x dx, right? So I'm going to have du over dx is equal to 2x. So you see that the process is almost the same. Like always, you choose your u, you rewrite the function again, making sure that you group your x aside and then all your u and the constant aside. And then now you come here, come and differentiate with respect to x. So like when you practice, you should be good, solving them. So now my du will be equal to 2x dx. Now I can replace everything here with this and then the 2. But if we cannot see, then what you need to do is, since you have this one here, you need to divide this one by 2, divide this one by 2, which is going to give us du over 2 is equal to x dx. So this is the same as this. So we are going to replace it by that. So this is going to be 2 this times du over 2. We are happy to cancel this and this, and then it will be left with, so let me just do a line here. This will be left with this. So we learned how to integrate an exponential function, right? We said maintain the function divided by the derivative of what is on the top. So the derivative of what is on the top is u, and remember we are integrating with respect to u. So it's like you are differentiating x, and what do you get? 1, right? So when I differentiate u with respect to u, I get 1. Like when I differentiate x with respect to x, then this is indefinite, so I add plus c. So this is going to give us u plus c, but remember to replace the u is x squared, and this is going to give us a final answer, which is so beautiful, u to the power x squared plus c. So a lot of hard work, but when you do the hard work, then smart work, follows. So that is the idea with everything. Let's do the last one. The last one is so nice. I know you can do it. Yes. You know your u already. So you see, that's how we do it. So when you finish, you can just get all the questions, and then try it yourself. Try doing it. When you get stuck, you can play the video, you continue, and then you'll be fine. So here I'm going to choose u to be equal to 144 plus x squared. Good. Then what will be my integration now? The integration here becomes 0 to 5 x divided by root of u dx. Why? Because now everything here is my u, which is here. I can write my integration as 0 to 5. So now I need to group the x and then the u. So I will have 1 divided by root of u is the same as u to the power 1 over 2, then x times the x, right? So now I need to go and look for this, the same process. So let's go here. Du over dx is equal to 2x, right? Then du will be equal to 2x dx. Let's find for x du. So we need to divide it by 2, and we have that. So we are going to replace x dx by du over 2, and we are going to have integration from 0 to 5, 1 over, or let me say that 1 over u squared, 1 over u to the power half is the same as u minus 1 over 2, because this is not 1. If it is 1, then we need to think about the natural log, times this guy here is the same as this guy here, which is the same as this. So we are going to have u divided by 2, and this is going to give us 1 over 2 out, u negative 1 over 2 du. Interesting. Then let's finish it up. This is 1 over 2 u minus 1 over 2 plus 1 divided by minus 1 over 2 plus 1. Integration from 0 to 5. So this one will be from 0 to 5. Now this is 1 over 2 u to the power 1 over 2 divided by 1 over 2. So 1 over 2 divided by 1 over 2 is 1, because like a divided by a is supposed to give us 1. So it's like 1 over 2 divided by 1 over 2. 1 over 2 times 2 over 1. This cancel that, this cancel. So we are going to get 1. So here is going to give us just u half, right, from 0 to 5. Let's plug them in. No. Good. So remember, this is not for u, so we need to go and look for u. This is u here. So we are going to have 144 plus x squared from 0 to 5 before you do the plug in. So always be careful with integration by substitution. So now let's plug in 5. This is 144 plus 5 squared minus 144 plus 0 squared. Think I need space, so I'll drag this guy up here, and then I'll drag this guy to up here, and then push this guy here so that I can continue from here. So let's write the final results. This is going to be 144 plus 25 minus 144, right? So 144 cancel 144, and we are happy to announce that our final results is equal to, this is our final solution. So let's write the solution. Pick one. When you finish, then we put some red box on it, meaning that we are done with this video, right? I hope you enjoyed it, and if you didn't understand, try and replay the video and then go through it, right? So I wish you all the best in your exams. I know, yes, you will do well. Yeah, I wish you all the best, and also see you in the next video.